Wow.
Okay, so we have A, B here, B here, and C here. Okay, the length of the perpendicular from A to BC means that we are looking at this line that connects from point A to BC in a perpendicular manner. Okay, that is what the question is asking for. Alright, so since we have already found in part I the area of triangle ABC, which is what? Someone give me the answer? 48. Okay. And then you have also found out what is the respective length of AB, BC, and AC. Right? Okay, so to find the length of this perpendicular, we make use of our answer in part I. How do we make use of that? Area of triangle ABC is not limited to just half times base AB and the height over here. You can always change your perspective such that the area is half times BC times the perpendicular length that you want. Okay? I'll just call it height. Okay? BC, your value already found. What is the length of BC? 10. Okay, so this area is supposed to be equal to 48 units square because it's the same triangle one. It cannot be that you take a different perspective then your area change. Right? So BC being 10. So your height would be equals to 48 divided by half divided by 10. Okay, so I'm sure you can calculate that in the calculator. Right? Next, question 9. We want to show that the points A, B, and C are the vertices of an isosceles triangle. Okay, what is an isosceles triangle? What's the definition of isosceles triangle? Both two sides are the same length, right? Okay, so in this case, it might be helpful to draw out the diagram to have an understanding. It need not be to scale, so long as you know roughly where does all these points lie. So A is negative 1, 2, maybe around here. And then B is 5, 2. So you know that this is on the same horizontal line. And then C is 2, 5. So 2, 5, maybe up here. Okay. So now to find out whether it is isosceles triangle or not, rely on the definition that there must be one pair of equal length. Okay, so we just go and find out what is the length of AB, BC, and AC. Okay, can someone tell me what is the length of AB? Anyone manage to find? 6. And then BC is 4.2426. And AC is 4.2426. So either you leave it in truncated by SF, in fact best is to leave it to exact, so your square root, your cert. So if I were to leave it to exact, can I know what is that value? 18. Okay, so to actually complete it as an entire proof, we say that since AC equals to BC, then triangle ABC is an isosceles triangle. Okay, so that's how we show it. Right, with all the working now. Okay, I'm just skipping all the working. I trust that you can do it. Right? Then in part 2, to find the area of triangle ABC, you'll find that it will be almost impossible to find the area if you did not draw a diagram. Because if you don't have diagram, you wouldn't be able to know what is the base and what is the height. Okay, base may not be a problem, since it will just be one of the lengths here. Okay, but the height will be a problem. Okay, so you need the diagram to tell you that if I choose AB to be the base, which is the convenient one, the height will be this part here, which is the difference in the y coordinates. Because the y coordinate here is 5, the y coordinate here is 2. So the difference will be 3 units. So the area of the triangle will be half times 2, half times the base AB, which is 6, times the height 3. So that will be 9 units squared. Okay? Confidently that D is actually in the midpoint of it. If this were not to be an isosceles triangle, then you will have problem in doing Pythagoras theorem. Okay. Alright, let's look at exercise 4B. Okay. We have done this similar question before, right? P is this, Q is this, and R is this. Question says that they are collinear, meaning to say they lie on the same straight line. So the gradient of any segment will be equal. So we just have to look for the gradient of, let's say, PQ. Okay, that will give us -3 minus -2. Over 2 minus 3. So this will give us -1 over -1. So this is 1. Then we need to find the value of Z. So maybe we find gradient of QR. If you want to choose PR also okay. So that will be Z minus -3 over 8 minus 2. Which simplifies to Z plus 3 over 6. And the gradient is equals to 1 because they are on the same line segment. Okay, so your Z plus 3 will be equals to 6 and then your Z will be equals to 3. Okay, so that's how we find the value of Z for question 7. Right, then exercise 4C, question 9 and question 12. Here we have part I, x over 3 plus y over 2 equals to 1. To make y the subject of the formula, that means you want y equals to something. So we slowly move things to the right hand side since our y is here. So y over 2 is equals to 1 minus x over 3. So y is equals to 2 times 1 minus x over 3. You may leave the answer this way, but for the purpose of the remaining parts of the question, I believe the intention is to have it expanded, which is 2 minus 2x over 3. Or of course you want to write 2 minus 2 third x also can, negative 2 third x plus 2 also can. They are all equivalent. Okay? Then, okay, part 2, find the gradient of the line. So now that I have transformed it into here, what is the gradient of the line? Listen. -2/3. So the coefficient of x. So no need any calculations. It's just reading off the equation of the line. Then in part 3, find the coordinates of the point at which the line cuts the x-axis. So cutting the x-axis means what? What does it mean? Intersect, yes, and then more importantly, y is equals to 0. So when y equals to 0, we solve for x log. Okay, so total x equals to 2, x equals to 2 times 3/2. So x is 3. Okay. Then last one, question 12. With gradient 3. So since the gradient is already told to us to be 3, I can say that the equation of the straight line is y equals to 3x plus c already. I just need to go and find out the value of c, for which I have the point 3, 1. So y is equals to 1, x is equals to 3. I will see that c is equals to 1 minus 9, that's -8. So y is equals to 3x minus 8. Okay. Part 2, hence find the coordinates of the point of the intersection of the line in part I with the line y equals to x. If I want to find intersection point between two lines, what do I have to do? What do I have to do? If I want to find the intersection point of two lines, do the substitution method or elimination method. Essentially, it's solving simultaneous equation. Okay, so 1 equals to 2, x equals to 3x minus 8. So x is 4, y is also 4, since y equals to x. So the intersection point, we have coordinates 4, 4. Okay. Any other questions? If not, can you please submit your homework to the front?